Subscribe my channel by pressing red button. Today my topic is ruby laser. This is ruby laser. It gives a red color laser beam as output. Actually, it was explained by maiman in 1960. The material required, the main material, that means the active media used in this material is a ruby rod. The chemical composition of this ruby rod is Al2O3 and Cr2O3. Why? Because the 0.05 percentage of aluminum atoms are replaced by chromium atoms. That means 0.05 percentage of its atomic weight of aluminum atoms are replaced by chromium atoms. So here the minority atoms are chromium atoms here. So first of all, I would like to explain about the construction of this experiment. First of all, we have to consider a ruby rod, a cylindrical ruby rod of length order of centimeters, and the diameter is an order of millimeter. Here the ends of this rod must be flat. This must be flat, and this end coated with a silver, that means a fully silver end. We have to make it coating with a silver. This should be completely silver, like a mirror, and this end is coated with silver but which is partly coated. This is called, actually this ruby rod is called the active medium or active substance of this experiment. These two ends, this silver, fully silver and partly silver ends are called cavity resonators. Here this active medium produces and amplifies laser. This cavity resonator amplifies the laser and also decides the output direction of the laser. Keep this ruby rod in a glass chamber or glass tube. Then take a xenon flash lamp surrounded around this glass equipment and connect with a high potential difference. Here these two holes, these two tubes represents the circulation of water. That means when this system is working, it gets heated, so you have to supply some water through this inlet and the hot water. The cold water enters from this inlet and hot water exits from this end outlet. Now let us check the functionality of this apparatus. Whenever we switch on this device and when we apply the potential device, then this xenon flash lamp glows. Whenever this lamp glows, it supplies light energy to the active medium. In this active medium, the chromium atoms or minority atoms, they get excited and they goes to excited state. Due to repeated flashes, this excited atoms also comes to the ground level before its lifetime. Then it gives a stimulated emission. Then there is a beam of laser beam in this end. That means a laser beam, that means the atoms gets excited While they coming to the ground level, they release some laser beam like this, a light beam like this. Then actually this ray hits this end and gets backward direction and moves in this substance. Meanwhile, this radiation collides with lattice points in this substance and then it collides at this particular position. It travels with high energy and they get emitted or emerged from this end. So this is a coherent beam. Coherent beam this is called laser beam. Now the energy diagram of this laser beam is, this is E1, this is, and this is E2 and this is E3. Here E2 is called metastable state. This is lower energy level, this is higher energy level, this is metastable state. Here after absorbing some energy, the atoms goes to the excited level directly. They won't comes to ground level from excited itself. They assemble here, the more number of atoms assemble here and slowly they comes to the ground state and meanwhile it releases a coherent radiation. This is called laser beam. Releases laser beam. Here actually these atoms absorbs 5600 angstroms approximately, which represents a green color. That means by absorbing green color, these atoms gets excited and they goes to the excited level and they comes to metastable state. While the atoms moves from excited to metastable state, they won't release any radiation. But from this to this, that means metastable state to ground level, they release energy. That means the wavelength of this emerged laser beam is around 6943 angstroms at red region. Right? Region. It emits. So, this is a somewhat failure experiment in my knowledge because it cannot give a continuous lasing action. It gives discontinuous laser. But this is the first laser. We know this is the first laser, like very coherent, unidirectional. So it shows the characters of laser, but it is discontinuous. Because whatever material we have chosen is a solid type material which is very stable. The atoms in this substance also very stable. If we supply some energy, it gives immediately reaction. That's why the process is very fast. In actually, the lifetime of atom is very, so that's why it gives certain energy and it stops for some time. And another thing is the xenon flash lamp, which consumes more power, like 30,000 volts around, and it flashes like white light. So white light means we know the combination of 7 colors. So but these atoms are absorbing only green color wavelength only. green color wavelength only. Among these WebGR colors, it absorbs only green wavelength only. Remaining wavelengths are gets wasted. So these are the disadvantages of these lasers. So to get a continuous laser, we have to utilize a gas molecules here. So gas lasers are very stable when compared with this solid state laser. Okay, this is very important question. You prepare well. Okay, and subscribe my channel. Okay, and write your valuable comments. Okay, thank you.